Welcome everybody. It's my great pleasure to be here from the summer break at the Frog Geeks Green Tech Talks. Today it's my great pleasure to welcome Mr. Martin Franze today with us. Welcome, Martin.
Thank you for having me. Great to be here with you.
It's an absolute pleasure, and it's also a human hour there for you in the US, so all good here. We are also happy to receive more information about the revolutionary way how that you bring across on how we can manage synthetic and organic waste. We're pretty excited about that. As you know, with us at Frog Geeks, talking all about sustainable building and living, we live and breathe this topic. So once again, thank you for taking the time, Martin.
Yeah, and thank you for taking the time to learn about material remediation and the product process and how this innovative and revolutionary formulation of enzymes can help alleviate the challenges in the landfill and composting waste management process.
I love this. I mean, it's absolutely, you nailed it basically. With the area, we have a big problem with waste management. Everybody knows that, we are looking for ways how to manage or how to prevent even creation of waste. So I believe this is a great addition and complement to the portfolio of the tools we have to work with. So let me give our viewers and our listeners a quick intro on yourself. And, I invite you then to add more on this topic, of course. So our guest today is Martin Franze. He has an education and a passion in the food science segment. He has also a chef degree. He's a seasoned business innovation strategist, and for several years, almost 2 decades, a clean tech investor. He's now coming with this idea of how we can manage synthetic and organic waste in also creating new resources, creating useful material or even new soil that we can then utilize to increase yields, etc. So it's my great pleasure to welcome you today once again. And with this, also like a little introduction to our viewers and listeners that do not have so much knowledge around this topic. Can you tell us a little bit more about what is the secret component? You mentioned already enzymes. Can you tell us a little bit more about, what is the composition of the product? How does it work? So we kind of give a little bit of an intro on this.
Thank you, Jenna. Yes, material remediation has developed a all-natural, non-GMO process with the proprietary compilation of all naturally sourced enzymes and microbials that are found in soils. With the organization or compilation of these enzymes, we've found them through extensive R&D to digest organics, synthetics, and plastics. This is done in a typical 10-week process, and there is a composting protocol that helps to create an environment that is best conducive for the enzymes to do what they do. And that is digest the waste, eradicate and digest pathogens and volatile organics into a stable, living, nutrient-rich soil amendment in a short period of time that is remediated, safe for earth use, and a new terminology that I think will become more prevalent in the handling of the climate challenges, which is earth energy. And the earth energy at the rhizosphere, and it's the top 8 inches of soil. And this makes the soil more habitable and promotes the commodities to grow at their genetic potential for the production and facilitation of photosynthesis, which when photosynthesis is stimulated to its genetic potential, absorbs carbon, and then off gases nitrogen and oxygen and all of the value adds that are good for humanity, the planet, and business.
Mm. Well, thank you so much for sharing with us this kind of insights on the product, on the solution itself. Now, I also indicated in the beginning, very very gently, some kind of background on this. But what was the real motivation behind, creating or kind of going deep in this solution? We know there are environmental problems. Those of you that can that follow us visually with the presentation that we share with you, what was the environmental problem that you're tackling with this solution?
Gosh, that's a big question and a lot of answers, a lot of challenges. It was, really to meet the capitalistic market disconnects and inefficiencies in how waste is handled. And then once we sort of open that can of worms per se, it really evolved into so many other value add benefits, and then overlapping it with the United Nations environmental programs, 17 Sustainable Development Goals, looking at that from a very surface level. The MR product process directly addresses 13 of the 17 SDGs, which is tremendous when looking at trying to resolve the global climate challenges for Agenda 2030, for example. The economic sustainability, economic development interests, where you can help with education, you can help with inclusion and diversity, jobs and food security, clean water, sanitation. Each of those can be an individual silo in how a community interacts with its citizens, and then how it interacts with the environment, and then how business is done. So it ultimately turns into a win-win-win. Win for humanity, win for business, and win for the environment. And it trickles down. So when you divert waste from a landfill, you have a carbon capture opportunity that can be traded on the commodities markets. When you look at the waste diversion, you're eliminating the challenges in the landfill, then you're converting the waste stream into saleable commodities that have carbon value, nutrient values, and then you're selling them into marketplaces like agriculture, horticulture, Department of Transportation, Department of Interior. The concentration of micronutrients in the soil amendment as it comes out as a saleable commodity is very living micronutrient dense. So it can be considered a blending agent, different than compost, different than mulch. So the ratio that you would redistribute it onto the land would be significantly less, meaning that it goes a lot further. So 1 ton of the MR soil amendment finished product could be distributed, for example, on a quarter of an acre. So you'd spread it very thin, like 1/8 of an inch to 1/4 of an inch. And then you water that in, and that'll reintroduce the microbial food web that's in the soil amendment into the rhizosphere, and then have the rhizosphere then regenerated to where you're introducing the microbial food web so that it allows the land to, 1, process minerals and make minerals and nutrients more available for plant uptake, as well as allowing the nematodes and the bees and the birds to come back to the land, which then reverses migration away from that land. So the animals will come back all the way up the food chain to the lions and the elephants and the zebras, will
Mhm.
return to the land that was desertified because you're bringing the living micronutrients back into the soil, which is allowing the soil to retain moisture, and then that repairs the water tables over time.
Mhm. So when we look at this particular slide, at slide number 20, for those of you that follow us, and you just now touched on so many points around the process, from waste management, perception, onto really this holistic thinking and systemic thinking of regeneration, and how these new economic opportunities can be captured. It's a very interesting concept that you now describe. We have now this beautiful flowchart on what are the inputs, and also potentially some application. You also mentioned what is the difference, or where does it sit versus compost or mulch. What are the, for example, optimal conditions for having this solution applied, and also to kind of maximize its efficiency? How much is the capacity, or how much waste can we treat? I have so many questions, so my apologies if I just kind of throw them all at you. I also try to take some notes that I don't forget. But maybe you can tell us a little bit more about the basic process. What kind of maybe co-products can be leveraged, or can be produced during processing waste or converting it into new material?
Good questions. A lot to unpack here. I'll try and address each one. And if I miss anything, just bring the question up again.
For sure.
The material remediation product process is a simple process of composting. It's a traditional windrow turners, grinders, shredders, water trucks, front end loaders, screens. So, then you have the inputs. We like to look at who is our exit buyer, what are their interests, what's the volume of feedstock,
Mhm.
what are the needs of the operations and the community into which these feedstocks and volumes are being generated. Is there sludge from a municipal waste facility that is contaminating the air or the water? What are the chemicals that have been buried in the landfill? We can source the existing buried landfill with screens, eddy currents, and magnets to then use the waste that's been buried as a blending agent, along with the new income waste streams of organics and synthetics, to be shredded and then windrowed, and then the MR inoculant or compost accelerant is added into the water truck and implemented into the pile.
Mhm.
And then the typical composting process is utilized, and the application of the MR microbes is a single application. The lifespan of the microbes is 10 weeks, and you would run the compost pile for 10 weeks. You can start to screen the finished product out of the compost pile as soon as 20 days, depending on the concentration or the blend of organics to synthetics, and what the exit buyer interest is. If it's going into road base for the Department of Transportation, or to be blended as an aggregate into cement, different feedstocks, different cycle times for the composting process. If you're really manufacturing for the agricultural industry, or the Department of Interior for the addressing of chemically burned or the repair of fire ravaged land, the feedstock blends may be slightly different, with less synthetics, a higher organics concentration.
Hmm.
The uniqueness about that is that the cycle time is faster, meaning that most of your product is going to be screen ready, pathogen free inside of 5 weeks.
Okay.
Then
Hmm.
you screen that anything that's not digested can be folded into a new pile
Hmm.
for further degradation and digestion of the microbes blended with the new feedstocks. So
Hmm.
you do come up with a zero waste solution
Hmm.
into which, in most cases, 100% of the waste that's then screened and sorted and placed into the compost piles for the enzymes to digest does get digested and turned into a remediated, safe for use soil amendment to go back to earth for earth energy.
Hmm. And okay, so thank you so much for sharing this. Now, so there are different outputs, different channels how you can then further utilize the material which is created. Are there any also particular environmental? I mean, you mentioned water, we mentioned land contamination, we mentioned also in terms of energy. How much more energy efficient is this process compared to what is available right now? If you have a kind of like a comparison, what is happening right now in terms of especially landfill management or operations, municipalities dealing with waste management?
You know, each facility is unique. That's a good question. Some facilities are less innovative to coming up to the times, and some equipment is older. The operators are less in tune to the innovations and technologies. So when you do find a facility that is antiquated, the value add benefits are much greater when adopted and implemented over time. You can tweak the operations, upgrade the equipment, upgrade the personnel, and really maximize
Mhm.
the operations and the outputs and inputs can be broadened.
Mhm.
Um, it's it's a it's sort of a paradigm shift into the way that a material recycling or material recovery facility
Mhm.
is operated today, into where we change it to a material remediation facility.
Mhm.
You collect and sort out the different commodities, sell them off into the current commodities markets. Anything that is outside of that is then shredded and composted and turned into saleable commodities, namely being soil amendment, topsoil, compost, and mulch.
Mhm.
The
Mhm.
um, the innovative adoption of the material remediation product and process is an economic acceleration model for landfills and material recovery facilities,
Mhm.
being that you can turn them into economic accelerating outputs that typically would be buried and now can be sourced from buried, blended with incoming streams,
Mhm.
and can remediate the landfill to a safe for use piece of land.
Beautiful. I mean, we know all the stories, or many of us know the story of, I don't know, this 40 meters tall mountains or even more kilometer wide, wherever they are in US. You have yours in Brazil. There are theirs in Africa. It's also a story. So, but you have this everywhere, and there is always, of course, also this topic on less land or not enough land, depending also, of course, on the location and the expansion, the needed expansion of landfills. So I think it's a very interesting concept, and many times it's a difficult discussion or this thinking. With we have now the whole circularity topic coming more, being more adopted, especially for us here in Europe, sitting in Europe. How does that compete or complement the concept of circularity, landfills? You mentioned now it's actually an economic acceleration. How do you see that? What's your perspective on that?
I think there's a great value add and a consciousness shift of current regulators and operators within the contracted facilities to look at this as a enhancement to their revenues, enhancement to their margins, and an efficiency that allows them to create a greater throughput, driving more revenue through tipping fees and shorter cycle times, into where instead of just collecting money on tipping fees to take the waste and bury it, now they can collect the money on tipping fees, increase the amount of tipping fees because they can broaden their collection opportunities, create a shorter cycle time for producing exit commodities, and get paid to sell the commodities as opposed to just selling out recycling. They now can manufacture commodities and sell those off. And that's really, I think, the more innovative solution set, is that you can source the buried waste in addition to broadening your intake tip volume in a small piece of land. So that's where you get that economic accelerating model. It creates much greater efficiencies on a particular plot of land. And I think once the current operators get an understanding of how this actually works to their benefit, there is a possibility that the municipalities will want to mandate something like this because it's good for the business, it's good for the environment, and it's good for humanity.
I got you. And now you mentioned also, thank you so much for sharing this. I mean, it's truly a paradigm shift, and it's a very interesting discussion, especially in this segment on waste. So waste is also a word that I don't really like. For me, it's like an excess material. So as you mentioned, material remediation, it's maybe something that we need to kind of move towards to. I would be very happy about that, of course, when we also do it, not only talk about it nicely. And going back to the process and being more technical here, are there any specific synthetic maybe materials that you have particular capacity to decompose or to process in this waste management application, or with your material remediation solution or enzymes? Or are there any particular materials that are super suitable, or are there maybe some materials that you would like to mention that are maybe not so suitable to our audience here today?
Yeah, good question. And the enzymes, being all natural, naturally sourced, are indigenous to soil, regardless of which continent you're on. It's very similar to the enzymes in our gut biome, and how, as a human, as an animal, regardless of which continent you're on, your enzyme compilation in your gut and in your digestive tract are similar, if not identical. Therefore, your body has the ability to digest different food types or different inputs. The enzymes in themselves are much happier digesting nitrogen soft organics. However, they are, in their excitement of digesting organics, do go through chemicals solvents, tanned leathers, steel belted radial tires, uh, baby diapers, Dorito chip bags, plastic bags. There's, basically the contents of general garbage does get digested miraculously. If we were to say, is there a more desirous feedstock? It is organics. The human waste, biological waste, agricultural waste is far easier and far more desirous with the enzymes to digest. So in the screening process, if there's an ability to take out your harder plastics, the PVCs and the laundry detergent bottles, the single-use toothbrushes and razor blades, those are something that would be better off put into a pyrolysis process as opposed to put into this waste stream with the expectation of going to an organic soil amendment. It does take a lot longer, and it's not the best use of time as a feedstock element for this process. Can it be done? Yes. However, it's not the main focal point of the material remediation enzyme accelerated digestion process.
Which is great. I really support your point to being transparent on what it can do, but also being wise around the best application. We have so many options now, so let's really be wise on how do we choose to use one method or the other, and just kind of assess it transparently. So, but when we talk about, and looking also a little bit at the time, with few more minutes left, now let's talk a little bit more about the money. It's always interesting. So how is it in terms of investment and costs connected to that, efficiencies that maybe a municipality or a landfill operator can achieve? What can you share with us on this?
So depending on the volume, what the landfill operator is taking in as far as feedstock or tipping fee revenues, what their operating costs are, we tend to run the inoculant based on an organics digestion per ton. And the concentrate of the microbial inoculant is sent out in gallons. So for example, 1 gallon of MR compost accelerant is recommended to digest up to 64 tons per gallon. So in a 5-gallon barrel, you could treat up to 320 tons of organic waste.
Mm-hmm.
In a 55-gallon drum, 3,500 tons of organic waste.
Mm-hmm.
In a 265-gallon tote, that treats up to and digests up to 17,000 tons of organic waste. Now, if you're going into synthetics, the blending ratios are slightly different. We do want to look at what the feedstocks are, and sometimes those will increase the concentrate application of the MR.
Mm.
So you're digesting less tonnage.
Mm-hmm.
That is a solution that per site, per waste stream, we like to evaluate and consult each facility. But the revenue or the cost associated, we have a suggested retail value of $1,500 for digesting up to 320 tons, and that is a cost basis of about $4.69
Mhm.
per treated ton.
Yeah, which already gives us a good indication on the cost that you need to invest to treat or to manage the waste in other ways. So this is great. This is great. Thank you so much, Martin. Now, maybe also before we move to the last question of today, and please, if you would like to stay in touch and reach out to Martin and the team of Material Remediation, make sure that you like, follow, click, comment on this video or on the comment section below, so we can contact you back or we can reach out with some more details to Material Remediation team. Of course, you can find them on froggeeks.com, so you know this. And maybe also Martin can share with us some direct details, some direct contacts to reach out to him. It's a great thing that you have also this consultation piece for partners that are interested, because it's very difficult as a newbie in this segment, maybe also piloting and testing this solution to kind of, get your hands on and really, make sure that it works, that you're happy, that it brings the result, and that you can kind of utilize the byproducts further. So this is something very, very good. And my question to kind of conclude this round would be, what can you tell us, or what can you share on the current pilots or applications that are running? What do you see? What are the feedbacks? Where can we see material remediation is particularly well working, or what is the feedback that you received there?
If you were to go to, and thank you for that mention, materialremediation.com has a very basic landing page informational site with a contact us form that you can reach out, submit inquiries to then have us work directly with you on setting up a demonstration or pilot within your facility. Each facility is different, the equipment's different, the feedstocks are different, and the operators are different. And therefore, we like to work at a demonstration level, whether it's 200 tons or 2,000 tons. We can meet the needs of the facility and wherever you'd like to get started. One thing I do want to sort of focus on is the next page in the slide, if you would, Jenna, the consumer product, which is the Alpha Compost Soil Amendment by Material Remediation. This is the additional revenue stream enhancer based on the living micronutrient-rich soil amendment that's produced, and the suggested retail value that would then uptick the revenue for the MRF or the landfill or composting facility by creating a highly desirous, profitable soil amendment product that is sold out as a blending agent, and the recommended usage is 5 to 10 tons per acre as a distribution. And that's producing with some farmers, horticulturists, greater yields, shorter cycle times, requiring less or no chemical fertilizers, and a more nutrient dense, a nutritious food. And that is a value benefit to the farmer. And then the families that are buying these commodities need to eat less food. They are healthier human beings. The animals are healthier, and the food, in its sense, is better for the consumer, requiring less food to have a more calorie dense more nutritious fruits and vegetables.
Excellent, excellent. So this is great. So for everybody interested to kind of step in, get in contact with Martin and his team on potential pilots or test projects, more than welcome. With this, I would say thank you, Martin, for your time today for this great run through and intro to the world of the enzyme way of treating waste. More than welcome. This is, what we love to talk about more. And I see we have a question here from Peter Brunner towards the end. Peter, this is your call. We take it, of course. It's the last question. So let me read it out. Is there any running implementation in Africa? Which total amount of organic waste and which percentage of ingredients is your concept requires? Thank you so much for the question, Peter. Please, Mike.
Thank you, Peter. At the moment, there is no running demonstration in Africa. We're working diligently within Africa and the World Vision International, WASH Global, and other entities within Africa, South Africa, Zambia, Zimbabwe, Nairobi, or Kenya. If you have a location or a valued interest in seeking to do a demonstration or a pilot at a facility or within your municipality, certainly reach out to me. We're more than interested in getting this product over to you. We have the ability to ship at as small as a 5-gallon bucket up to multiple 265-gallon totes to fill containers that we can send you then thousands of gallons of concentrate to scale up to address the economic development goals of your community, region, or country. The feedstocks, the most ideal feedstock for the enzymes is a higher concentration of organics. Organics can be biologics, that can be agricultural residues, it can be food waste, which is also generated through agriculture, but anything that has water in it is considered organics, into where that is I would say that the best concentration would be 65% organics to 35% synthetics. Synthetics can be your textiles and clothing, softer plastics, styrofoam cups, styrofoam clamshell to-go containers, anything that says it's a compostable or biodegradable product. This would shorten the cycle time of the biodegradation with the enzymatic mediated accelerated decomposition into a healthy, safe soil amendment with a high concentration of living enzymes that then is very valuable as an indigenous reapplication to your land to create a more fertile land that will grow commodities better. So you keep it in the community. Anything that you have as a surplus of soil amendment that can then be sold off outside of the community to bolster economic development, job security, and
Absolutely.
so forth.
I love to see that we have also our bamboo friends here. Big greetings, big shout out to our friend Fred Hornaday. As you say, we also love to see farmers turning residue into revenue. For sure. Why not to use it smartly, wisely, eco-friendly? That's certainly a way. So thank you so much to everybody for watching our stream today. If you would like to reach out to Martin Franze, once again, thank you so much for taking the time, and his team from Material Remediation, please reach out or just let us a comment in the comment section, and we see you on the next talk. Thank you so much, everyone.
Bye for now.